Okay, so when you're finding mathematical models, the first thing you want to do is take a peek at the data. So we're going to insert a chart. We have to make sure the chart we're inserting is a scatter plot. So scroll down and choose scatter plot. And the thing to notice about this is that it is not a straight line. A straight line is not a good model for this relationship. It looks like it's curving, and so we think parabola. And so what we're thinking is y is proportional to x squared. So that's what we're thinking on this one. So what we're going to do is we're going to take our data and we're going to transform it. So I'm going to copy my data here, and I'm going to paste it next door to it. And I'm going to keep y. I never mess with y. I always mess with x. And I'm going to plot the velocity squared because I think y is proportional to x squared. And so I'm going to write a formula. First of all, I'm going to clobber these numbers, and I'm going to write a formula. I'm going to say y equals x equals what was over here, the velocity. I'm going to raise it to the power of 2. And of course, you could do this with a calculator, but it's a lot faster to write a formula. So what I've done is I've squared all the velocities, and so now I think I'll have a linear relationship. So I have y, I have x squared. We'll take a peek at this. I think that it'll be a straight line, so I go to scatter plot, and there it is. It looks like it's a fairly straight line. It looks like a straight line is a good model for this relationship. So then I go to customize. Under series, I can have the computer determine the line of best fit, and you can see a straight line does a very good job of modeling this data. I go down here to label, and I tell it to use the equation. So the computer thinks y equals 0.44 times x. But you got to be smarter than a computer. You know that on the y-axis it's really the force, and on the x-axis it's really the velocity squared. So instead of using the equation, you're going to use a custom label, and we are going to put the formula in here. So instead of y, we're going to have the force equals 0.44 times, and instead of x, we're going to put the velocity squared. And since this trend line appears to go through 0, 0, I'm going to ignore the small intercept that was given to me on the trend line. So there's my mathematical model there. Okay, so the only thing you got to do from this point on is fix your title. It needs to be in context, and add your labels. And so when I do that, it's going to look something like this. Okay, so here's my finished graph. On my y-axis, I have force because I graph force on my y-axis. On my x-axis, I have the velocity in meters per second, and that is squared. It's important to note on the label that it's squared to get a straight line. My mathematical model, I move to the middle here. It's y, the force equals 0.44 times the velocity squared. And then I have a title, the relationship between the force and the velocity, and then I have a context for a rock moving in a circle. Okay, so for the second set of data, we quickly take a graph, look at a graph of it, take a peek and see what it looks like. Always make sure you're using a scatter plot. And it looks like it's a reciprocal relationship. It looks like as the distance goes up, the intensity goes down. So my first guess is that there's a reciprocal relationship. So I'm going to copy my data and paste it over here. And when I paste it, I'm going to take, I think y equals 1 over x. So I'm going to write a formula here. I'm going to take 1 divided by x and graph that and see if that straightens it out. And so take a quick peek at your data here again. And it's a scatter plot. And it looks like it's starting at 0, 0, but it still looks like it's curving. It still looks like a parabola. So not only must I take y equals 1 over x, but it looks like I've got to square it as well. So that's your clue. So instead of taking y equals 1 over x, we're going to take 1 over x squared and graph that on the x-axis, 1 over the distance squared. So this is 1 over d squared, and the intensity. And when I graph that, we'll see if that straightens it out. So we go to scatter plot, and it does look like a straight line. So now we're going to finish this up. We're going to go to series and add a trend line. A trend line does a good job of fitting the data. So that means that what's on our y-axis, the intensity, is proportional to what's on our x-axis, which is 1 over d squared. Down under label, we can tell it to use the equation, and it looks like 4.7 is our slope. And so we can finish it up by using a custom equation or label. And on our y-axis, we have the intensity equals the slope, 4.7, times our x-axis, which is 1 over d squared. So we just got to make sure we get that mathematical model correct. And then we're going to add a title. We're going to label the y-axis intensity. The x-axis is going to be labeled 1 over the distance squared, because that's what we had to graph to get it straight. And we'll put a final title on there. So when we do all that, it's going to look something like this. So there we go. Here's my finished graph. My title, the relationship between the intensity and the distance. The mathematical model is I equals 4.7 times 1 over d squared. I have labels including units, and here I put distance in meters, and the whole thing is raised to the power of -2. So 1 over distance squared. And that's how you finish that one up. Okay, and then on the third one, you can just skip it. It turns out that you have to graph the temperature to the 3/2 power to get a straight line, and that's a little more complicated than I intended. So just skip that one. On the final exam, of course, you'll need to remember that it might be y equals x, it might be y equals x squared, it might be y equals square root of x, or y equals 1 over x or 1 over x squared. So those are the mathematical models we've looked at so far.